Hello, I am 1B students. Let's go over your Unit 3 exam review number 1. You should have a pen or something of color in your hand, and you should be looking at your exam review that you've completed as you watch this video. You should make any corrections and note any errors that you have made along the way as if I was in class with you. So make sure you're really taking your time here. This is our time together for you to make sure you're getting it right before your test on Friday. All right, number 1, it says answer the following using the picture provided. Name the figure in question E. All right, question E is a point, and that would be point A. So we would name this figure point A. If you just put a regular capital A, that's okay too. Figure F, A, B. Remember, this is an array because we start off at point A, we go through point B forever and ever in one direction. That's an array. Make sure you have that notation correct. A, B with an arrow on top going one direction. So as you're checking this, 2 capital letters, and this notation is really important. Name the figure in question G. This is called a line because it extends forever and ever in both directions. This can be called line AB. And remember, a line can also sometimes be named by a lowercase cursive letter, which we don't have in this case. A figure in question H, this is a segment AB because it does not go on forever and ever. It has 2 well-defined endpoints. Notice a difference between question C and question D. Question C indicates going on forever. Question D indicates not going on forever, 2 endpoints A and B. Name the figure in question I. There's a couple ways we can do this. This is called plain, and we can name it by the capital cursive letter in the corner with no point associated with it, so plain M. Or you can name the plane by 3 non-collinear points. So in this case, you could say plane ABC, BCA, whatever your heart desires. All of these things are really important for you to remember, so if you need to, take a second, go back, and write down my pointers for you on how to name geometric figures correctly. All right, number 2. Can A be, oh, this is a little crazy because of the math type. Can AB and AC be opposite rays? Sure. A through B and A through C, sure enough, can be opposite rays because opposite rays need to share an initial point, then extend forever in opposite directions. So yeah, this would definitely work. Since we don't have too much more information, I think so. Question 3, point B is between. Remember, between means 3 collinear points, then it's in between. Use a segment addition postulate to solve for x, then find the lengths of AB, BC, and AC. Segment addition postulate tells me a little segment plus a little segment equals a big segment. So let's draw a picture indicating or like showing us point B is between A and C. So point B is between A and C, and B is somewhere between, we don't know where. A to B is 13 plus 2x. B to C is 12. And A to C is x plus 32. So the equation we need is a little segment, AB, plus a little segment, BC, equals a big segment, AC. So we would say 13 plus 2x plus 12 equals x plus 32. All right, let's do some algebra here. So 13 plus 12 is 25. 2x plus 25 equals x plus 32. Let's move that x over. And let's move that 25 over at the same time. Why not? 2x minus x is x. And 32 minus 25 is 7. x is 7, but that's not the entirety of the question. It asks us to find out what AB is. So let's plug it back into that expression. 13 plus 2 times 7 is 13 plus 14, that's 27. So segment AB is 27. BC is already given as 12. And 7 plus 32 is 39. So AC is 39. Then you ask yourself, does this make sense? Does 12 plus 27 equal 39? Yes, it does. So it seems like we did a good job there. Question B, very similar. Let's draw it up again. Point B is between A and C on a segment. We don't know where, but it's fine. A to B is 8x plus 5. B to C is 5x minus 9. And A to C is 74. So remember, a little segment plus a little segment equals a long segment. So in this case, our equation will be 8x plus 5 plus 5x minus 9 equals 74. Let's combine like terms on the left-hand side of the equation. 8x and 5x is 13x, and 5 minus 9 is negative 4 equals 74. If we add 4 to each side, 13x equals 78. Divide both sides by 13, and we get x equals 6. Remember, that's not all the question's asking for. It's asking to find the lengths of the segments. So we could plug that back in. 8 times 6 plus 5 is 48 plus 5. That's 53. Right? Yeah. And 5 times 6 minus 9, that's 30 minus 9, that's 21. And double check. Does 53 plus 21 equal 74? The answer is yes, so we've done a good job here. All right, number 4, in the diagram, let's label this stuff up. From Q to U, that has a value of 58. So Q, sorry, give me a second. Q to U, the full line, has a value of 58. All right. S to U equals 12. RS is equal to ST, I'm going to put congruence marks, is equal to TU. If these two are equal and they're equal to 12, then that means each part has to be 6. So this has to be 6, 6, and this also is 6. 58 minus 18 is 40. That's how much this is. So let's kind of find out what it's asking me over here. RS, how much is that? R to S, that's 6. RT, R to T, 6 plus 6, that's 12. R to U, that's 18, 3 times 6. Q to R, Q to R, we found out to be 40. And Q to S, 40 plus 6 is 46. And Q to T is 40 plus 6 plus 6. That would be 40 plus 12, which is 52. Remember, these congruent statements mean they all have the same length. All right. Identify the segment bisector of ST, then find ST. Looks like this cut up a little bit, so let's say this is point R, and the segment bisector would be ray RM. Remember, the segment bisector is the thing that does the cutting. And because we have congruence marks, we can set these two expressions equal to each other to solve for x. X plus 12 equals 8x minus 2. Subtract x from each side. Add 2 to each side. 7x equals 14, x equals 2. And it asks you to find the measure of ST. ST is the full line segment. 2 plus 12 That's 14. So this also has to be 14. So ST has a length of 28. That's the full segment. All right. Over here, the segment bisector is the thing that does the cutting. In this case, we just have a point M. So point M is a segment bisector. All right. These congruence mark tells us that we can set those two equations equal to each other. 2x plus 3 equals 4x minus 7. Subtract 2x from each side. Let's add 7 also. We'll get 10 equals 2x, so x equals 5. Let's plug it back in to find out. 2 times 5 plus 3, that's 13. This is also 13, so the full segment is 26. All right, angle addition postulate is just like segment addition postulate. A little angle plus a little angle equals a bigger angle. Find angle BAD. BAD is the sum of these two angles added together. So 31 plus 24 equals 55 degrees. That's the measure of angle BAD. Find angle X. This is a linear pair or a straight angle. So together, these add to 180 degrees. So we could say 2x minus 18 plus 4x equals 180. A little angle plus little angle equals the larger angle of 180. 2x and 4x is 6x minus 18 equals 180. Let's add 18 to both sides. We get 6x equals 198 divided by 6. X is 33. And that's all the question asked of us, so we're good. Oh, up here it says find the measure of each given angle. Fine, we can do that. 33 times 4, that's 132. 2 times 33 minus 18, that's 48. The figure shows the design of an outdoor fence. Name the pair of adjacent supplementary angles. All right. Adjacent meaning next to, supplementary meaning adding to 180 degrees. So two angles that are adjacent and supplementary, for instance, could be angle 1 and angle 2. Angle 1 and angle 4. Angle 5 and angle 6. Angle 4 and angle 3. There's a lot, so any of these, really. Hopefully you can see a pattern. All right, number B. Name a pair of non-adjacent supplementary angles. Two angles that are not next to each other and add to 180 degrees. All right, well, if this angle is 160 and together they add to 180, then this is 120, this is 120, this is 60, this is also 120, this is also 60, this is also 120. So angle 1 and angle 8, those will be non-adjacent and supplementary because they're not next to each other but add to 180 degrees. Angle 2 and angle 5. There's quite a few more examples. Identify a linear pair that includes angle 5. Angle 5 is right here. So this direction, 5 and 6. Makes a straight angle. And the other one would be this direction, 5 and 8. Oops. Okay, find the measure of angle 3. Well, angle 3 is congruent to angle 1 by vertical angles. So angle 3 is 60 degrees. Name 3 pairs of vertical angles. Angle 1 and 3, we just said. 2 and 4. 5 and 7. And just in case, 6 and 8. All right, last question. Use a diagram to find the angle measure. Given BAE is 130. So angle BAE, the full angle, is 130. So 3x. So this angle plus this angle plus this angle equals 180. I'm sorry, 130. My bad. 3x minus 10 plus 2x plus 5 plus x plus 15 equals 130. Let's combine like terms. 3x, 2x is 5x plus x is 6x. Negative 10 plus 5 is negative 5 plus 15 is a positive 10 equals 130. Subtract 10 from each side. 6x equals 120. Divide by 6 and x is 20. All right, let's see what they're asking us for here. Find the measure of angle BAC. That's here. So how we would find that is plug in x equals 20. 3 times 20 minus 10. 60 minus 10, that's 50 degrees. CAD is here. 2 times 20 plus 5 is 45. And lastly, DAE is here. X plus 15, that would be 20 plus 15. That's 35 degrees. All right, you guys, I hope that you followed along diligently. I hope you're preparing for your test. If you have any questions, you can ask me. Remember, this video was made for you by me as if I was there with you in class. So if you need help, just pause, go back, double check, and if you have any questions, you can send me an email. Work hard on your Unit 3 exam to review.